Tensegrity is a structural concept that combines rigid elements and elastic tension elements, much like our body does by having the elastic elements, like our muscles and tendons, really hold the whole structure together. Because of the way they are held together through this elastic network, when you impact them, when you push on them, the force of that contact distributes through the whole system, and so that makes them very robust. Where we are today with tensegrity research is that we've really advanced this field from its inception, probably even less than a decade ago, to today, where we're really starting to grasp the fundamental engineering concepts required to design, build, and control these robots.
Modeling and simulation is pretty crucial to the research that we've been doing with tensegrity robots, specifically Superball. The Superball project is a NASA-funded project where we are trying to come up with new ways of doing robotic rovering for space exploration. What I've been working on using the modeling and simulation is using machine learning techniques with our simulator, figuring out ways to move the robot. The machine learning that we're using is called guided policy search, which is a research algorithm out of UC Berkeley. So we're working in collaboration with UC Berkeley to learn how do we optimally move it through a certain space, and then trying to train a controller to do that so it becomes reproducible. For the system that we've built, we've had to design a lot of our own electronics. I've designed and developed all the electronic boards on the system, and that included making our own types of sensors and exploring different techniques and how to merge those sensors together to get the full state of the robot. Then we use that information with machine learning techniques and the simulator to explore ways to move the robot.
So UARC has played an important role in the research of tensegrity robots at NASA. From the very beginning, UARC funded some of our internships that did our very first research and simulation of tensegrity robots that allowed this project to go forward. In addition, it fostered the collaboration between UC Berkeley, which is very important in developing some of our early prototypes, and also continuing our tensegrity mission for such projects as the tensegrity for the Moon.
Tensegrity structures can really influence the future of NASA's ability to explore the solar system, because it's going to enable us to make revolutionary new planetary exploration systems that can land on another planet, a lot like an airbag, where the robot itself can absorb that impact. Therefore, you can do all sorts of new, interesting forms of exploration that would be considered too high risk today. You could explore the edges of cliffs. You could explore really rugged terrain where there is a good possibility of slipping and falling. And maybe that's where the good science is, where you really want to do your investigation. So we want to go there, and so we need the technologies that can handle that kind of risk.